Alright, section 1.1 is on page 1, talks about propositional logic. A proposition is a declarative sentence, that is, it's a sentence that declares a fact. There must be a fact in that sentence. That fact is either true or false, but it can be both. So it can be true and false at the same time. And this is on page 13 in the book. It's asking which of these are propositions. What are the truth values of those that are propositions? Number 1, do not pass, go. That would be a command, so that's not a proposition. What time is it? That's also not a proposition. Doesn't list any facts. That is a question. There are no black flies in Maine. Well, that is a proposition. It lists a fact. The fact is that there are no black flies in Maine, but I don't know if it's true or not. If there are black flies in Maine, then it is true. If there aren't, then it is false. So I'm not sure whether there are black flies in Maine or not. D, 4 plus x equal 5. Well, this is not a proposition. Its truth depends on the value of x. If x is 1, it's true. If x is not 1, that's not true. The moon is made of green cheese. That is a proposition, but it's false, because the moon is not made of green cheese. And 2 to the n is greater than 10. Again, that is not a proposition. Anytime there's a variable, it can be a proposition, and the truth of that depends on the value of n. Now, a couple of definitions as we go on. Not that we're going to use all of those, but these are going to come up as we move throughout the course. Propositional variable or centennial variables, those are variables that present proposition. So instead of listing the whole proposition, we normally use common letters P, Q, R, S. We say let P be this proposition, Q be another, and so on and so forth. Atomic propositions, again, there are no definitions on the exam. You just need to kind of understand those as we read and move throughout the book. Atomic propositions are propositions that cannot be expressed in terms of simpler propositions. Propositional calculus or logic is the area of logic that deals with propositions. Again, they might use those terms. Compound compositions are new compositions that are formed from existing propositions using logical operators. Now, our first definition. Let P be a proposition. So P is some statement. The negation of P is denoted by, now all of these right there represent the negation of P. So the proposition negation of P is read, it is not the case of P. So the truth value of the negation of P is the opposite of the truth value of, if P is true, then the negation is not true, and vice versa. Now, I'm going to be using this notation because it's easy to find on my keyboard, but the book is going to use this. So I'm looking at number 4, and it says, what are the negations of each proposition? So, Janice has more Facebook friends than Juan. The negation of that would be Janice does not have more Facebook friends than Juan. B, Quincy is smarter than Venkat. The negation of that, Quincy is not smarter than Venkat. C, Zelda drives more miles to school than Paula. The negation of that would be Zelda does not drive more miles to school than Zelda. And the last one, Brianna sleeps longer than Gloria, and obviously the negation of that, Brianna does not sleep longer than Gloria. Now, the truth table. We're going to be doing truth tables as we do logic. Again, this is the symbol they use. I'm going to be using this. So, if P is true, then the negation of that is false. And if the proposition is false, the negation of that is true. Definition 2. Let P and Q be propositions. The conjunction of P and Q, denoted by P conjunction, so this is like P and Q, is a proposition that B and Q is true when both P and Q are true and false otherwise. Definition 3 talks about let P and Q be propositions. The disjunct of P and Q, denoted by, this is P or Q, or both in this case, is a proposition that P or Q or Q is false when both are false, otherwise always true. So if I look at the truth tables for conjunction, this is AND. So AND means you must satisfy both. The only time this will be true when both of those are true. If one of them is false, since it's AND, that's automatically a false. The disjunct, which is OR. So if one of them is true, automatically it is true because you satisfied the case. The only time it's not true when they're both false. Example 10 states, let P and Q be proposition. P is the proposition that I bought a lottery ticket this week. Q, I won the $1 million jackpot. Express each proposition as an English sentence. So the negation of P, since P is I bought a lottery ticket this week, the negation of that would be I did not buy a lottery ticket this week. When you're looking for OR, disjunct, it says P or Q. That would read, either I bought a lottery ticket this week or I won the $1 million jackpot on Friday. This would be the same statement except you would say and. So I bought a lottery ticket this week and I won the $1 million jackpot. And the last one, G, the negation of P, since P is I did not buy a lottery ticket this week, and since that's and I did not win the $1 million jackpot this Friday. Definition 4, let P and Q be proposition. The exclusive of P and Q is denoted by this plus, is the proposition that it is true when exactly one of them is true but not both. So only one of them is true. You can't have both of them being true. So this is kind of like the OR, except the OR does represent one or the other or both. Here, it can only be one of the two. It can be both. Conditional. If P and Q are proposition, the conditional P implies Q is really if P, then Q. This is called a conditional statement. The if part must be satisfied before you can jump and conclude the Q. And says the conditional P implies Q is false when P is true and Q is false, and true otherwise. If the conditional statement P implies Q, in that statement, P is called the hypothesis or the antecedent, and Q is called the conclusion or the consequences of that P. And example 6, definition 6, they talk about biconditional. This is if and only if, so that works forward and backward. P if and only if Q. You could move forward. It's if P then Q, or if Q then P. So here the only time that would be, well, let's do the table and we'll figure it out. So this is one or the other. If both of them are true, then this is automatically, so since this is one or the other, if they're both true, that's the truth table would be false. Only one of them could be true. And if they're both false, that's automatically false. Conditional, P implies Q, or if P then Q. If P is true, then Q is true. If P is true, then P is Q. That's a false statement. If then, if it rains, there must be clouds. You can't say, well, it did rain and there were no clouds. That's not possible. If the original is false, if the P is false, then the conclusion is true regardless. Now, biconditional if and only if, remember, if P then Q, if Q then P, well, they both must match. So, if this is true, then this is true, and vice versa. If this is true and that's false, if you reverse it, that doesn't work. You can say if it's false, then it's true. And the same deal here. And here, if you swap those, you still get the same conclusion. Next example up is number 10. Let P and Q be the proposition. Again, P, I bought a lottery ticket this week. Q, I won the $1 million jackpot. So if I would like to write, express each of these propositions as English sentences, if I look at part C, it says, if I bought a lottery, so if I bought a lottery ticket this week, then I won the jackpot, the $1 million jackpot. E, the by states, if I bought a lottery ticket this week, if and only if I won the $1 million jackpot on Friday. F, not P. If I did not buy a lottery ticket this week, then not Q. Then I did not win the $1 million jackpot. And the last one, if I look at H, that would be, this is or. So either I did not buy a lottery ticket this week, or I did buy one and won the $1 million jackpot on Friday. $16. Let's have P, Q, and R to be proposition. P, you get an A on the final exam. Q, you do every exercise in the book. R, you get an A in the class. Write these propositions in terms of P, Q, and R, and logical connectives, including negation. All right. So A, you get an A in the class. That indicates P. Oh, you get an A. You get an A on the. You get an A in the class, not on the final. That's R. But you do not do every exercise in the book. And you did not do every, so that's negation of Q. In B, you get an A on the final. You get an A on the final. That's really P. You do every exercise in the book, so this is and you get an A in the class. That's R. C, to get an A in the class, it is necessary for you to get an A in the final. So this is conditional. That is, it's necessary to get an A on the final. So if you get an A on the final, then you will get an A in the class. Let me think about that. Yep, you get an A in the class. So it's necessary for you to get an A on the final to get an A in the class. So if R, then statement B. So those are written, you gotta read it backwards. D, you get an A on the final exam, which means, which one is that? An A on the final is P. But you do not do every exercise in the book, so and negation of exercise. Exercise, I believe, was Q. Nevertheless, you get an A in the class, so it's an AND as well. An A in the class is R. E, getting an A on the final and doing every exercise in the book is sufficient to get an A. If you do those, then you will get an A in the class. And lastly, you get an A in the class, that's R, if and only if either you do every exercise or you get an A in the final. So conditional, if P, then Q. Contrapositive, you reverse the order. The inverse, negation of P implies a negation of Q. When two compound propositions always have the same value, we say they are equivalent. So, looking at the next problems, determine whether each conditional statement is true or false. 1 plus 1 equals 3, that's false. Then unicorns exist. Unicorns don't exist. B, if 1 plus 1 equals 3, well, this is false. And the indication, then dogs can fly. Well, they can't fly. If 1 plus 1 equals 2, that is true. Then dogs can fly. Dogs cannot fly, except for superpower. And if 2 plus 2 equals 4, that's true. Then 1 plus 2 equals 3, that's also true.